Hello everyone. We discussed today in previous lecture we already discussed the half-life period of radio element. In today's lecture we discuss about the average life which is shown by capital T of radio element. The average life is shown by letter T. Then it is the time of radio element over which an atom of radio element can exist. That average life is a time over which an atom of radio element can exist. We know that if we consider all 100% atoms of radio element, then all the atoms of radio element cannot disintegrate simultaneously. All atoms of radio element cannot disintegrate simultaneously. Some atoms disintegrate and convert to new element, new atoms of new element, while at same time some of the atoms remains as it is, that is they not disintegrate at that time. Therefore that half-life concept of half-life and average life is exist. If all atoms participate or all atoms disintegrate simultaneously, then no concept of half-life. All that atoms simultaneously converted into new element. But this one is not happen. Because of we know that if we consider 1 kg of any radio element, consider half-life period 10 years. Then after 5 years, what will happen? That 50% atoms will be converted into new element, atoms of new element, and 50% atoms remains in original form. Then after again in next 10 years, that half kg of original amount again converted into 250 grams. Then next 10 years that converted into 125 gram. Then next 10 years, that is next half life, that converted into 62.5 gram. As like that, a time will be reached when that radio element no more exist, that amount become 0. Therefore that means 50% in initial, if we consider initial rate of disintegration amount is 1 kg initially, we considered amount is maximum, rate of radioactivity is maximum. Which one is proportional? Directly proportional to amount of radioactive element. Therefore initially amount is more, disintegration rate is also more, and as amount decreases, rate of disintegration decreases. That means first 50% atoms, major number, disintegrates in first 10 years, if, as we considered 10 years as a half lifetime. That one is major amount. Then in next 10 years, actual amount if we consider, if we compare initial original amount, then 25% atoms. As like that, rate of disintegration, atoms will, number of atoms that goes on decreasing as time increases. Therefore average life, if we calculate for radioactive element. It is the time of, or it is the life of radio element over which an atom of radioactive element exists, or it is the life of radio element over which that radio element can exist. It is ratio of total life of all radio element atoms to the total number of radioactive atoms. That average life is a reciprocal of decay constant, that is T is equal to, average life T is equal to 1 upon lambda. 1 upon lambda. Then relation between average life and half life. Average life and half life. We know that half life, that is T half, is equal to 0.693 upon lambda. Here replace that 1 upon lambda by capital T. Therefore, that T half is equal to 0.693 into capital T. Therefore, capital T is equal to T half upon 0.693. That is 1 upon 0.693 into T half. That 1 upon 0.693 is nothing but 1.433. Therefore, average life T is equal to 1.433 into T half. 1.433 into T half. This is that equation for that average life capital T. Remember that capital T is equal to 1.433 into T half. Then units of radioactivity. That radioactivity power of radio element measured by following units, using following units. First unit is curie. That 1 curie is a quantity of radio element or radioactive material which produces 3.7 into 10 raised to 10 disintegrations per second. Therefore, 1 curie is equal to 3.7 into 10 raised to 10 disintegrations per second. 1 curie is equal to 3.7 into 10 raised to 10 disintegrations per second. Then 1 millicurie, that 1 millicurie is equal to 3.7 into 10 raised to 7 disintegrations per second, and 1 microcurie is equal to 3.7 into 10 raised to 4 disintegrations per second. Then next unit is Rutherford. 1 Rutherford is quantity of radio element which produces 10 raised to 6 disintegrations per second, which produces 10 raised to 6 disintegrations per second. Remember that. Therefore, that 1 Rutherford is equal to 1 into 10 raised to 6 disintegrations per second. 1 Rutherford is equal to 1 into 10 raised to 3 disintegrations per second. And that relation between Curie and Rutherford is 1 Curie is equal to 3.7 into 10 raised to 4 Rutherfords. The next unit is Becquerel, which is shown by letter BQ. That 1 Becquerel is a quantity of radio element which produces 1 disintegrations per second. 1 disintegration per second. Therefore, that here relation between query and becquerel is given. One query is 3.7 into 10 raised to 10 becquerel. One query is 3.7 into 10 raised to 10 becquerel. Then we discuss some problems based on half life and rate constant equation, half life and average life equation. See here, if we try to solve, very simple problems are these are. The activity of a radio element falls to half of its original value in 5 hours. Half of its original amount in 5 hours. That is 5 hours is T half. Then calculate decay constant lambda, average life capital T, and the time required for the activity to reduce to 1/10 of original value. 1/10, that is that original amount divided by 10. Consider original amount is 1, then n0 is 1, then n is 1 upon 10. N is 1 upon 10. Then lambda is first calculate decay constant. T half is given 0.693 upon T half. Then capital T 1.433 into T half. T half is given, and activity that time required, that one is lambda. Decay constant equation, we remember this. Lambda is equal to 2.303 upon T log of n0 upon n. n0 upon n, where n0 is consider 1, then n0 upon 10, 1 upon 10. Consider that values. Then rearranging that equation, we require here time. Therefore, T is equal to 2.303 upon lambda into log of n0 upon n0 upon 10. Then that consider that 1 upon 1 upon 10, then that become 16.57 days. As like this, next problem, if you consider what is rate of emission of alpha particles from 10 raised to minus 3 gram radium-226 if its half-life is 1620 years. T half is given, convert that into days. Then 1620 into 365 into 24 into 16 to 60, that is second, years into second. Then lambda is equal to 0.693 upon T half. T half is already given, that is nothing but 6, that 1620 into 365, that one is second. Therefore, lambda is 5.104 into 10 raised to minus 9 second. Then number of atoms for any element we can calculate as mass of that element in upon molar mass into Avogadro's number. Mass is given, that is what is the rate of emission of a particle from 10 raised to minus 3 gram. Mass is given. That means number of atoms, how will you convert? Mass upon molar mass. Molar mass, molecular weight 226 into Avogadro's number. Then number of atoms 2.665 into 10 raised to 18 atoms. Then rate of decay, which one is lambda into n. Lambda into n. Therefore, lambda is there, n is there, n is number of atoms. Therefore, that number of particles we obtain as a 3.615 into 10 raised to 10 alpha particles. As like that, here problems are given. Solved problems are already given in our notes. Then from that you solve other problems from another publication book and from question papers. For problem solving, practice is very important. Practice is very important. Therefore, solve problems from another textbook. Thank you. We in next lecture we discuss uses of radioisotopes as tracers. Uses of radioisotopes as tracers. Thank you. Hello everyone. Hello everyone. In previous lecture we discussed that nature, this one only disadvantage. Then second scintillating material is zinc sulphide. It is so very useful for measurement of alpha particle counting. Then another one is anthracene and stilbene.